Welcome to 7th session of Hypermesh Radio's interface demos. So in this session I'll be showing demo on two separate topics. In that one of the topic is model check. So I'll be checking I'll be checking this model by taking into consideration of various aspects, like maybe the connectivity is one, and the check from the solver perspective, and some of the visual checks. And the second topic will be how to create engine files. So these are the two topics on which I'll be giving the demo in this session. So let's jump to the model. So here I have a model from session 6 where we created all the output blocks. Now to find connectivity, I'll come to here. I'll go to tools and we have an option find connectivity. So earlier, and even now also we have this old option where we use find and we keep on finding the components which are connected to maybe one component or multiple components. That is still there, but that is good when you are just finding maybe the neighboring components. But if you are checking the connectivity at the full model level, then you may have to repeat that step maybe multiple times to say that all the components are connected. So for that purpose, we have this new option wherein you can find the connectivity of entire model at once. So I'll be showing that here. Okay, it will open a separate browser. I will say find connectivity. So here it is telling like it will find the connectivity using by considering all these different connections. So if you have a particular case where if you want to ignore some of the connections, then we can do that as well. In this case, I will select just all the possible connections and I will select all the components here. Okay. And one more thing here is this connectivity check in the model building process. You have to do it soon after you complete all the connections. So you have done with the meshing and you have done with the connections. So that is the stage at which you have to check the connectivity of the entire model. So here I'm doing it at the last phase of model building just because I wanted to do the multiple check in one session. That's why I brought it here. Otherwise, the normal practice is once you are done with all the connections, at that stage itself, you have to you have to do this activity. Okay, so that is one clarification. Okay, it is running the connectivity check for the full model. So if the complete model is well connected, if you have a well connected model, then ideally you should see only one group. So one group which has all the components. That means your model is well connected. It is completely connected. But in this case, of course, we expect, apart from one group, we expect this impactor also to be in a separate uh, group or free part. So that is what it is telling. I have a impactor which is separate and the rigid body which is separate. That is fine. I will not worry about them. They have to be separate. But there are some other parts which are also free. Okay, so this is a cause of concern. So as per this, I have the tires which are not connected. Okay, so initially the idea was to connect tire with the rim using the tight contact, which I didn't do in the connection phase. So as of now, these tires are free. So now I have to connect these tires. So for that, I'll come to okay. So let me pick these components. isolate. So I have to create a tight contact between these two. So I will do that. So for that I will create a contact. Okay, so I'll name this as between rim and wheel, and it will be a type 2 contact. So for that master I will pick it as these components. Okay, and for nodes I pick them. So in type 2, like it is better you select the nodes which can project with the master surface, but in this case if you see it is quite tedious. So I will remove some extra nodes manually, but I will not put much effort into this one because I have one solver option. By using that, whichever the solver nodes which doesn't have a projection, I can make that to automatically get ignored from the contact. So I will do that. So I have removed some of the nodes and I will say add. Okay, so here in the ignore I will use option as 1, so that will take care of those nodes which doesn't have a projection. Okay, so now I'm done with that connection. That is good. So next again I'll go to this connectivity and I'll perform the same operation again. Okay, with the full model. And select all the components. Okay, and check. So I expect now those tiles are connected with the model, and I will have one big group with two free parts. Yeah, so I have that one. So with this, yeah, I can be sure that the model is well connected. So let me switch off this connectors. Just hide them. Or even hide it, the type 2 contacts. Okay. Okay. So now that is on finding the connectivity. So the next important check I will move for the solver check. So that we have in the tool, and so we have model checker as per solver. Okay, so I will run this checker. So this is a important activity. Uh, most of the errors which will come here, so if you don't correct this and if you run these models, and then those are the errors which will come in the solver at the starter level. So it is better to correct these errors. Having said that, it will also populate some of the errors where you have to take some caution maybe. Like it may say that there are some maybe springs whose one end is free, uh, because if it's both the ends are connected, uh, then it is okay. If one end is free, it will not get caught in the free connectivity also. But that is not an issue for the solver. But from the connectivity point of view, yeah, that may be still an issue. So some of the errors are here are just a caution. So you have to just keep in mind that whether you have to really address that error or you can live with that errors. So when we see error here, it doesn't strongly mean that it will be a solver error. So it will be a point of caution also. So I will just run this model checker. So it will check the model for all these different entities, and it will populate some errors. So for some errors, there is an automatic correction which preprocessor will suggest that it can correct it automatically. And for some, yeah, you have to do the manual corrections. Okay, it is running the checker. So basically, some of the error related to the rigid body, they are quite an important errors, depending on the way you have connected them. In the connection section, so have given some specific guidelines that how you have to create the rigid bodies. So if you have not created as per that, you may see some errors here, and when you run the model also, it can create a lot of problems. So here in the rigid body section, yeah, majorly I'm not seeing any errors. Uh, so it is telling like some components are missing the material, but they are specifically the spring components. So either what we can do is we can declare that it's a spring. Okay, so okay, I have come at the I'm at the part level now. Okay, but spring doesn't require any material. Okay, so but these components, having said it is a part, so normally part expects both property and material. In that context, it is telling so these are the components which doesn't have material. But if I can just isolate this part and I can verify what kind of parts they are. So in this case, all are springs. Okay, so I don't have to worry regarding that this error. Okay, it is just a caution in this case. Okay, it is talking about some property and material incompatibility again because of this spring property only, because I know all these are weldings. Sorry. So all these are welding. Again, they don't require any material, so it's only the property. So that is fine. I'll not worry about those warnings, those errors. And yeah, I don't have any other error in here. So it is suggesting in law 36, I have used some functions, but I have not used any value for fmooth and fcut. So it's a warning again. Uh, so if you have any suggested values or practices you can use for these values, but from the solver perspective, it will run even without those values also. So that is fine. And again, there are some values. So in the type 11, so in the context of type 11, I think we have used the value as iStiff as 4, but it is just picking a warning that iStiff is not equal to 0 or 1, because I'm going by soft approach, so it is warning me that it is 0 or 1, so it is something else. So if I want to change, I can do that here. And again, for the spot, by default, the spot flag will be set to 1. Yeah, the spot flag will be set to 1. So which may lead to some additional masses add. So it may add some extra mass. So that's why it is calling that as it's a bad spot flag. So if you want to change that, you can change the spot flag in that. And yeah, so this is particularly coming because of we created these two tight contacts, and there are some nodes which are not finding the projection. So this is what it is talking about. And as I have already told, I have taken some corrective action for that at the solver level by using the appropriate option. And there are some free nodes, okay, so which we will correct when cleaning the model. and there are some small rigits. Okay, so yeah, so there are some small rigits. So for small rigits, it is suggested to use ISPL as 1. So it is suggesting same thing that there is a non-spherical inertia. So I can change the flag for this at the card edit level. And select these rigid bodies, and I can change ISPR as 1. Okay, so next time when I run this checker, it should update this issue. So like that, there are some unused sets, there are some of the unused entities which are there. So I have defined the F cut for the sensor, so it is just telling me that I have used a frequency cut at the sensor level. So the idea of showing this is uh, whichever the errors which it populates here, you should have a fair idea that why that error or that warning is coming, and you should try if it is possible, uh, and some of the things you should correct, otherwise it will lead to solver errors. So if you correct at this level, then the number of errors what you face at the starter level, that will get minimized. Okay, so this is a neat option which you should do at the end of model building or model setup activity. Okay, now the other things what I wanted to show here, because since we saw many of the unused entities here, I want to show you there is a new option of cleaning which is unused. Okay, so earlier we used to do F2 and we used to get into each entities and see like if it is unused or if it is empty like that, and we used to delete that. But now it is a new option where it shows in the entire model which are all like unused or which are all empty. So in one go you can just select all of them and delete it so that you can keep your model clean. Okay, so I did that. So the other visual checks normally which I do is yeah, especially the contacts and the R wall. So this is a check which I do even when I create it also, and also maybe at this level. So I just want to review it and ensure that it has both master and slave, and also of course it has all the components. Okay, so this is the new contact what we created. So just let me see it. So I have the master and slave, that's fine, and I have yeah, I have the master and slave, so this is fine. Yeah, I have type 11 contact. Uh, this is fine. So from the type 11 perspective, it is fine, no issue here. But while creating the type 11 contact, so I mentioned that this is not a perfect region for type 11, because in the type 11 we expect a contact between edge to edge. Uh, here just to show the feature like how to create a type 11 contact, I selected this region, but otherwise to create a type 11 the perfect application is when you have the contact between edge to edge, then it's a perfect scenario. One example may be like if you have a seat slot like in the seat tracks, uh, you'll be having the seat slot, and in that you have a bolt which is locating, that travel, and if you want to create a contact between that, so that is maybe a perfect region for a type 11. But here, since it is surface to surface, we should have a type 7 also. So let me create that type 11 here at this stage, because I feel from the working point of view here it requires type 11, type 7 as well. Okay. So let me quickly create this type 7 contact. I already have a type 7 contact which, at the globally, so I will just clone that so that I don't have to enter the parameters. Factor to body again. Okay, so of course I have to make the new selections. So as per the thumb rule, I will make coarse mesh as master. Okay, and fine mesh as slave. Okay, fine. Oh, okay. So it is not taking it as the names are same. Okay, I'll review this. Okay, now I have a type 7 contact also. Fine. So these are some of the checks what you can do on at the full model level. Fine. So the next section is creating the engine file. Okay, so we'll move to that. So for that, you can see there is a engine file assist, but this has a very limited option. Like some of the very basic cards which is required in the engine to create that, we have this engine file assist. But for our like regular working, where you are working at a detailed level, so we need much more cards. So for that, it is better to create engine using this option, where I will go to create cards, engine keywords, and here the keywords are alphabetical. So you should be knowing like the significance of the cards to create this engine file. So now the four basic entries which are required for engine, I'll go from the order of its importance. Like first I have to specify how long this model has to run. Okay, I switched off the model browser. Okay, now to create cards, engine cards, and I'll come to run. Oh, okay. There is already a card here. Yeah. So I have to decide how long is the event, this event. So this I'm loading it for a span of 300 milliseconds. So I have to run it for 300 millisecond of zero point 0.3 seconds. So be careful about the unit system. Again, the unit system what I'm following here is Newton millimeter ton seconds. So it is 0.3 seconds. So this is the first information. Now again, uh, I create the card. So the next card is uh, anim dt. So which is how frequently you want animation file. Okay, so starting from 0, I want the animation at every 0.005 seconds, which is 5 milliseconds. Okay, again. So the next is t file. So So we have put many entities in the output block as a th part, th node, th inter, and all those things. So on those entities, it will extract the output to plot the graph. So here we are specifying that information should be extracted at what frequency. Okay, so basically a number of data points. So which is slash t file. Um, okay, I came to the starter here. Sorry, I should go to. Okay, so little my mouse is acting very sensitive here. Okay, so I will create the T file. So the T file again I have to specify at what frequency I want the data to be extracted. So this frequency will be normally smaller than the animation frequency. So animation I put it as 5 power minus 3. So T file I'm taking it as 5 power minus 4. Okay. And so in the TH, I mentioned whatever you put in output block or TH, the output will be in a plottable format or graph format. So we require many of the contour output also, like you may be requiring the stress, strain, and many other outputs. So that is possible using this option, which is anim. And so in the anim, as you can see, there are varieties of output which are possible. So depending on your requirement, you can select the appropriate one. So here I'm selecting some of the basic outputs. So maybe like EPSP, one message, and hourglass. Okay, so these are some of the basic one what I have selected here. Okay, so these are the basic engine cards. So apart from this, we have to select even the time step also. So since I know this model that we have built it for a particular element size, so I'm expecting this model to run with a particular time step. So I can choose that time step while running the model. So that command I can put it here. I'll go to DT. So it is DT Noda and it is CST. Okay, scale zero point 0.9 and time step 1 e power minus 6 seconds, which is 1 microsecond. So because while meshing, so I have controlled the element size. So there may be some small elements in this model, but it is meshed for with a particular size. So with that confidence, I'm putting that this model should run with 1 microsecond. And again, of course, when I start the run by seeing the mass error, if required, I may have to change this value. But this is the section where you put the timestamp. Okay, so now my model is ready to be exported. So that I will do it using this option and go to export. And here just make sure that whenever you export, the option is all here. Okay, and while exporting there are options like if you want you can merge both starter and engine file so that there is one file which has both, or you can keep them separate also. So now I'm going with an option where I want to keep it separate. Okay, I have exported the file. So you have starter and engine files here. see that. Yeah. Okay, so here the value should come 1 e power minus 6, whatever I have entered. Okay, it has not taken it. Okay, so sorry. Yeah. So maybe like I didn't hit enter there, so it was not there. Yeah, I can export even the engine file also separately. Okay. Yeah, it's updated. So now we have the both the files. So our next step will be to run this model. So this is the end of this session. Thank you.